How y'all doing today? So today's I went a little deep on this topic today because I'm sure you've heard a lot of introduction to X, Y, and Z. I want to talk about like next level stuff. So at Microsoft, my job, I am basically a sales engineer. The sales guys go out and say, of course we can do this for you. And then they come to us and say, okay, figure out how to do what we just promised them. And we work with some very large data sets, very impressive rates of ingestion. And one of the approaches that we use for handling that amount of data is what we're going to talk about. What it is directing streams with Kappa and Lambda architecture. How many people already know about these concepts? Maybe, okay. It's not going to be a lot of code. It's going to be more or less an overview so that you'll know where to look when these issues start coming up in your environment. And so right now, we're at the introduction. And as I said, we're going to be exploring the Kappa and Lambda architecture. We're going to examine their principles, understand their data flow, different components that make up the architecture, and hopefully you can walk away understanding what they are when they're applicable in your environments. So the first question you might have is, why does this matter? Basically, as applications consume more and more data and the needs of the business become more real time, if you think of some examples like, Amazon, who reports like 1 million clicks per second on their website. How do you handle that amount of data and present timely information? And it's not just the idea of storage, but ingesting that data so that it can be processed as close to real time as possible. So again, like looking at Amazon, where they're giving recommendations on, hey, since you're looking at this, you might want that. They're doing that as you click. So between one click to the next, they need to bring in that data, comprehend it, look at other similar data, and present to you those suggestions. And like a lot of people don't work in that large amount of data set, but when you do, it matters to understand how to address it, how to approach it, how to consume it, and how to process it. So first we're going to look at Kappa architecture. And basically, Kappa it's designed for handling specifically real-time data. So like I said, the click stream on an e-commerce website or something similar. Its primary principle is to use a single stream rather than as we'll look at with the Lambda architecture. The Lambda architecture splits the stream into two, one for real time, one for batch. Kappa architecture focuses on a single stream and putting it where it needs to be for both scenarios. It uses a unified data pipeline. So this is the basic architecture of Kappa. Your data will enter in through your single, can you see that? It'll enter in through your single data source, come into your real-time layer, which processes that data in real time, and pushes it into the real-time app, whereas it also stores the rest of that data for later batch processing for analytics and things like that for historical approaches. The key components are, like I said, the ingestion layer. You probably use something like a Kafka or another stream platform, and then a distributed storage like Hadoop or Cassandra. And basically, the idea is to allow the data to get to your real-time application as quickly as possible with minimal latency. The pros and cons of Kappa, basically it's simple because it's a single data pipeline. You're not managing collaboration between multiple data sets or data formats. The reduced latency, again, it's going straight from your stream into your main app, as I showed, in the yellow pipeline. So it's the hot path is what they call it. And then there's some challenges, of course. If you have to reprocess data, like if data comes out of order, or if you need to review data from earlier, that will also cause it becomes more complicated in those scenarios, and that's why you would look to the Lambda architecture to provide a different leverage its strengths to handle those edge cases. Again, here's some examples. It's been done again like e-commerce for personal recommendations. As your click stream comes in, you want to look at it and provide those suggestions on the spot. Social media, so as all of the tweets or Facebook post or whatever comes in, they want to process that and provide different trends and highlights. So when you see what's happening now on Twitter, you'll be able to see relevant, timely, important to you data. And a really interesting application is fraud detection in finance. So when you swipe your card and your bank says, oh, this looks strange, we're going to make you verify that this happened. That's what's happening, is that they're processing that data on the fly as it comes in and says, no, we're going to put this stop to that. And on the back end, of course, there are complex engines that it runs through, but it has to be in the time of a normal transaction. Normally, when you swipe your card, you get like 2 or 3 seconds before it says declined or approved, and the reason it takes a little longer is that it's also running through your fraud detection engine to look at trends and habits and similar scenarios that might indicate that this is a suspicious transaction. Specifically for one project I worked on, we had real-time sales tracking for a grocer, and they wanted to know stock and availability in real time, so that if someone needs to add more items from the back room onto the floor, they get an alert immediately rather than down the road. And so that's how Kappa architecture can help with real-time decision making, real-time insights, real-time actions. So next we can look at the Lambda architecture. And basically it's more of a hybrid system where you have both the real-time data and batch processing in one system. If you recall, the Kappa architecture did one pipeline where one was a push, one was a pull. And here with the Lambda, oops, sorry. Let me see if I can get my mouse over here. Well, here with Lambda, you have the data source, and it's being fractured out into two different pipelines. One pipeline is handling the transformation of, or the direct ingestion of the data for real-time processing. The other pipeline does transforms and things like that to prepare it for batch processing, which is later on an analytics process will come and look at it and do further analytics on it. Similar to Kappa, sorry, my page keeps going. Similar to Kappa, the Lambda architecture will use something like Kafka for ingestion, but they'll also use other tools for batch processing as well in stream. So the difference between Kappa and Lambda is that Kappa just dumps the data and relies on the batch processing to come after the fact. In Lambda, we're going to do some of the preparation of the data in stream so that it will be ready. What they also call it is a hot path versus a cold path. So the hot path would be the real-time analytics versus the cold path for the batch processing. Again, like I said, the Lambda makes up for the weaknesses of Kappa through fault tolerance, scalability, and again, like I said, Kappa wouldn't be able to handle things like out of order messages and things like that as easily. Lambda, because of its structure, is able to. Of course, with that higher capability comes more complexity. Specifically, because we're splitting the data, as those transformations change, it becomes more important to keep those two elements in sync in order, because it will be otherwise there'll be data inconsistencies. So again, that adds to the complexity of implementing the Lambda architecture. Some use cases for Lambda, smart buildings. So one instance, we worked with a smart panel manufacturer that reads HVAC data and electrical data from the entirety of the building. This was also an IoT scenario, so analyzing IoT data, lots of data points, lots of sensors, bringing in data rapidly, and being able to understand and act on those. So, like, for instance, if the temperature in a room is set to 75 degrees and the thermostat picks up that it's above that temperature, basically the system will be able to compensate and say, hey, turn on the HVAC for it. And in the house, the thermostat and the HVAC are directly connected, but like in a large building or skyscraper, the HVAC and the thermostat itself don't talk directly to each other, because an HVAC unit might have multiple zones that it controls. And so that's where it would go through an IoT system, go through the stream analytics and say, okay, well, this room zone is out of its desired range. Let's turn on the system for it. And again, with log analysis, so clickstream data, as we talked about in the e-commerce scenario, this will be different for this case, because we're looking more at trends across a group of people rather than just one user, what should we display to them? We're looking to see, hey, what are hot trends? How can we apply that to a larger group of people? So next we're going to talk about, like a direct comparison between the two. And basically they, like we talked about a lot, both of them are dealing with real-time data processing. The Kappa architecture is, again, like more designed for simplicity, for a system that leans more heavily on real-time processing versus the Lambda architecture, which is designed for a hybrid approach where I want real-time and I want to get a head start on my batch processing. So how do we select the appropriate architecture? We have to look at the data needs. What's the latency? If we want it out there as fast as possible, we want to minimize the steps between getting the data into the system and being able to act on it. You'll more likely lean toward the Kappa architecture. If you want scalability, tolerance, you're going to probably lean more toward the Lambda architecture because as your data needs grow, you're going to want to be able to have multiple feeds that can handle that rate of data ingestion. Let me see. Yeah, so those are the two endpoints of the spectrum. Of course, there are recent trends where people are trying to apply both. So, you have a Kappa and a Lambda, and I've never worked with that directly, but, the idea is to attempt to mitigate the weaknesses of each by relying on the strengths of the other. So, in summary, we looked at what Kappa and Lambda are. We talked about the pros and cons of them, and we did a direct comparison between the two. I don't have any, like I said, no code examples, but we could talk through the architecture and design, and if you have any questions, I'm glad to answer them. I usually leave space for that. Everyone gets it then? Anyway, thank you very much for attending, and y'all have a great rest of your of the conference.
Thank you, Michael. Thank you.